Hello. For this one, we're going to be solving shortage of first. As we know, shortage of first is a non-preemptive algorithm, but it has a criteria of choice. And the criteria here of choice is choosing the job or the task or the process with the least burst. Okay. Of course, when you choose, you need to choose among those who already arrived. So if there is a process that did not arrive yet, so it's going to be arriving in the future, it's not really among the candidates that you would be choosing from, okay? So let's solve the first problem. Here it is. So I have here this table, the processes, the arrival times, and the bursts. Let's do that. As you can see, the very first arrival is at time 4. So again, from time 0 to time 4, there is no remaining, of course, because this is idle. All right. And then we have process 1 that arrives at time 4, right? The process 1 has a burst of 5, which is actually bigger than the burst of P2, but the moment of choice, P2 wasn't there, right? So P1 is the one that is going to be chosen. It's going to be working from 4 all the way to 9. Why? Because the burst is 5, and of course the remaining time here is 0. Okay. Let's draw that. So from 0 to 4, it's idle. And then process 1 is going to be working from 4 all the way to 9, I believe. Yes, here's P1, and P1 is done. Now you have to pay attention that at time 9, when P1 is done, so it leaves the running state, and the processor becomes idle, you have 2 processes to choose from, P2 and P3. Why? Because P2 arrives at time 6 and P3 arrives at time 8. So at time 9, that's the moment that you're going to be choosing at. You have P2 and P3, both of them are candidates. As you can see, the burst of P3 is less than P2, so P3 is going to be the one to choose. So here P3 is going to be chosen. It's going to start from time 9 to 11. Why to 11? Because at time 11, because it has a burst of 2, all right? And there's no remaining time, as you can see. Let's draw that. So from 9 to 11, you have P3, and P3 is done. Now, at time 11, you have 2 processes. P2 that already arrived at time 6 and hasn't been chosen yet, and P4 that just arrived at time 11. If you look at the bursts, you will find that P2 has a burst of 4 and P4 has a burst of 7. So of course we're going to proceed with P2, right? So P2 is going to go from time 11 all the way to time 15 because it has a burst of 4 and the remaining time is 0. Why remaining times are 0 again? Because they are non-preemptive, assuming that none of them is I/O bound. So now we finished at time 15. So at time 15, we have few available processes. Okay, let me draw this. I forgot to draw that down there. So from 11 all the way to 15, you have here P2, and P2 is done. So at time 15, you already have P4 that arrived at time 11, P5 that arrived at time 13, and P6 that arrived at time 15. If you look at the bursts now, P5 is the one to be chosen. So you have here P5 that will start from time 15 to 16 because it has a burst of 1, and the remaining time is going to be a 0. And then, so let's draw this here from 15 to 16. You have here P5 and it's done. Then the next one to be chosen, the next candidate is P6 because it has a burst of 2, while P4 has a burst of 7, correct? So we're gonna run P6, right, starting from 16 all the way to 18 as the burst is 2 and there's no remaining time. So this is gonna be from 16 all the way to 18, that's P6, and then the final one is going to be P4, so here it is, P4, which is going to start at time 18 all the way to 25 because it has a burst of 7, and here's a 0, so this is going to be at 25 P4, and P4 is done. Now the waiting time again, because this is non-preemptive, it could be, you can use start minus arrival, or you can say it's the finish minus the arrival minus the burst. Again, I cannot stress on this enough. This equation is the general one that will run in all cases. This only works when the system is non-preemptive and all the processes, none of them asks for an I/O, okay, which is the assumption here. So the waiting time of P1, it arrived at 4 and it started at 4, so it's going to be 4 minus 4, this is going to be 0. If you apply the second equation, finish minus arrival minus the burst, it's going to be 9. Where did I get the 9? Here it is, see, 2, 9. So 9 minus the arrival time, which is 4, minus the burst, which is 5. This is also going to be a 0. 2, it started at time 6, it started at, 2, P2, started at time 11. And it arrived at time 6, so this is going to be 11 minus 6, so the waiting time here is 5. If you use the other equation, so it finished at time 15, as you can see here, 15 minus, it arrived at time 6, and the burst is 4, so this is also 5. Of course, it has to give you the exact same value. P3, it started at time 9 and it arrived at time 8. So here is going to be start minus arrive. This is going to be a 1. If you use the other equation, you will find that P3 finished at time 11. Here, 11. Arrived at time 8 and the burst is 2. So this is going to be a 1. W4, so for process 4. Process 4 started at time 18. It started at time 18. It arrived at time 11. So the waiting time here is 7. Let's apply the other equation. P4 finished at time 25 and arrived at time 11, and the burst is 7, so the waiting is 7. All right, 5. P5, it started at time 15. P5 started at time 15. It arrived at time 13. So the waiting here is 2. 5 finished at time 16. Arrived at time 13. And the burst is 1. So the waiting is 2. Of course, you have to get the exact same result. W6, so for P6, P6 started at time 16 and it arrived at time 15. So the waiting time here is 1 if you use the other equation. P6 finished at time 18, arrived at time P6 arrived at time 15, and the burst is 2, so the waiting is 1. Now how about the CPU utilization? Let's get sigma the burst. Sigma burst is going to be 5 plus 4 plus 2 plus 7 plus 1 plus 2. So here's a 10, 19, 21. That's the burst is 21, okay? And of course 21 plus 4, that's when you started. Here's 25, so the timeline looks good. So the CPU utilization is sigma of the burst, which we calculated, 21 divided by the total time. As you can see, the total time is 25, which is 84%. The throughput is the number of the processes, which is 6 divided by the total time. So this is going to be 0.24. Right? You can calculate the turnaround time. As you know, for every process, you're going to get the finish minus the arrival. And then you sum them all and divide by 6 because there are 6 processes. The response is exactly the same as the waiting time because this is non-preemptive and all of them are CPU bound. Okay, let's solve the second problem. So here the process 1 starts at time 5. So again, we have an idle interval from 0 to 5. Then P1 starts at time 5, right, because it's the very first arrival. As you can see, P1 has a burst of 2, so it's going to be from 5 all the way to 7, and you have no waiting time. And as you can see here, P2 arrives at time 8, which means that you have an idle time from 7 to 8. Process 2 arrives at time 8, right? And it has a burst of 4, so it's going to go all the way to 12 and no waiting time. No remaining time. At time 9, now it's 12, right? Look at the time now, it's 12. This means that you have P3, P4, and P5 in the system, right? P3 has a burst of 3, P4 has a burst of 2, and P5 has a burst of 1. Of course, we're going to start with P5. So here is P5. It's going to work from 12 all the way to 13, and you have a 0 remaining time. And then now it's 13. Your choices are P3 with a burst of 3, P4 with a burst of 2, and P6 with a burst of 2. I'm gonna be taking first come first serve between the equal bursts. As you can see, the candidates are P4 and P6, so I'm gonna be taking P4. So here is gonna be P4. It's going to work from 13 to 15, and the remaining time is 0. P6 follows from 15 to 17 because the burst is also 2, the remaining time is 0. And then now we have P3 remaining. So it's going to be 17 to 20 and 0 remaining. Let's get here. If you would like to draw this, you would. Let's just get the burst. This is going to be 2 plus 4 plus 3 plus 2 plus 1 plus 2. That would be a 6. 9, 11, 12, 14. Correct. 14. We started at time 5, so that would be 19, and we have one idle in the middle, that would be 20. That's when we finish. It's easier, of course, to see it on the timeline. If you would like to draw it, that would be from 0 to 5. You have here idle. And then you have from 5 to 7. That's P1, done. From 7 to 8, I believe that was idle, correct? So from 7 to 8, idle. At time 8, we started with process 2 with a burst of 4, so it's going to be all the way until 12. That's P2. And then at time 12, we selected P5, which has a burst of 1. Here it is, P5. And then at time 13, we chose P4 with a burst of 2. So it's going to be until 15, P4. Okay, all of them are done, of course, as this is non-preemptive. And then at time 15, we took P6. Here it is, from 15 to 17. Correct. This is P6. And then we took P3 from 17 to 20. Here it is. Again, here is idle, as you can see. And here is also idle. So here you have 5 idles, and here is 1 idle. So the total time for idle is 6. Plus 14, that would be 20. That's the time when we were done scheduling. Now again, you can use the weighting, either start minus arrival, or the finish minus arrival minus the burst. This time I'm just gonna use the first equation to save time. So P1 is going to be 5 minus 5. This is going to be a 0. It didn't wait because this is the very first one. Also, P2 is going to be 8 minus 8. This is going to be a 0, right? Weight 3 is for P3. Let's see, P3 started at time 17 and arrived on time 9. So this is going to be 17 minus 9. This would be 8. 4 started at time 13, as you can see, and arrived at time 9. So it's going to be 13 minus 9. This is going to be a 0. Oh, sorry, 4. This is going to be a 4 here. All right, and then W5, which is for waiting 5. It started at time 12, and it arrived at time 11. So the weighting here is 1. 6 arrived at time 13. It worked at time 15. So 15 minus 13, that would be a 2. So this means that the average waiting time equals 8 plus 4 plus 1 plus 2 divided by 6, which is going to be 15 divided by 6, that would be 2.5. And the throughput is going to be a 6 divided by the total time. As you can see here, the total time is 20. So if you multiply by 5, that would be 30% or 0.3. That's the throughput. The CPU utilization is going to be the sum of bursts, which is 14 divided by 20. This would be 70%. Okay, that's the CPU utilization. Again, the turnaround time and the response time you can solve now. Turnaround is the finish minus arrival for each and every one of them. And then you get the average by summing up the values and then dividing by 6, which is the number of processes you have. The response time is exactly the same as the waiting time because this is non-preemptive, and the equation is start minus arrival. Thank you.